right, this is part 2 of your 3-2 lesson on solving linear equations, and we're graphing. So for this part, we're going to be doing more estimating. You can check your answer by solving algebraically, just like we did on the first part of the notes here. Plug in 0 for y, solve for x. This part, we're going to be kind of estimating. We're not going to find an exact answer. We're not going to know what 0 is. We're not going to plug in 0 just yet. We're going to graph what we do have and get as close as we can by estimating. So here at the beginning it says, estimate solutions by graphing. Sometimes graphing does not provide an exact solution, but only an estimate. In these cases, solve algebraically to find the exact solution. So like I said, we can go back and plug 0 in for y, solve for x, no problem. But first we want to try and estimate with a graph. Excuse me. So for example, we got an example written out for us already here. You and your cousins decide to walk the 7-mile trail at the state park to the ranger station. Can you guys see all this? I don't know if you can. The function d equals 7 minus 3.2 times t represents your distance, d, from the ranger station after t number of hours. T is for time. Find the 0 of this function. Describe what this value means in this context. Okay, what does it mean when they say find the 0? Remember we just talked about it in the last video. Find the 0. To find the 0 of a function, it's finding the solution. It's plugging a 0 in for y and solving for x, right? So they started here. I haven't done any of this. They've written this out for us. They started here by making a table. So they have their t column and their d column. T is the number of hours, d is the distance, right? And if you're not sure which one is x and y, because it's still on a coordinate plane, so even if they call them different variables, one is still your x value, one is still your y value. Just look at your graph. What is being measured on the x-axis? Time in hours, t. So I know t over here is my x value. And then what's being measured on the y-axis? The distance from the ranger station, d. Okay, so they plugged in a few numbers here for t. They put it into the equation given, d equals 7 minus 3.2t, and they solved for d. And they got the distance, right? So when they plugged in 0, they were 7 miles? 7 miles, yes. They were 7 miles from the ranger station before they even started, right? They were 7 miles away from the ranger station. They did not take one step yet. So at 0 time, they're still 7 miles away. After they've gone 1 hour on this 7-mile trail, when we plug a 1 in for t, we get a distance of 3.8. So now they're 3.8 miles from the ranger station. So our ordered pair that we would graph is over here, right? So we started off with 0, 7. That's this point right here. Now we have 1 and 3.8. So over 1, up 3.8. They kind of estimated here. And then the last one they used was 2. When they plug a 2 in for t, they got a 0.6 for d, which is right here, like almost halfway up here. Okay, so these are the 3 points that they got in the table. And they went ahead and drew a line through them, right? And your line is infinitely long. You can keep on going. So if the solution is where I cross my x-axis, this t-axis here, well, I haven't quite got there yet, right? I plugged a 2 in for t, and I got a 0.6 for y. But the solution is when y is 0, so I'm not quite to 0. So since 2 is almost to 0, I'm going to go down one more. I'm going to try a 3. So when I plug a 3 into my equation, d equals 7 minus 3.2 times 3. 3.2 times 3 is 9.6. 7 minus 9.6 is negative 2.6, right? So this, is it negative 2.6? Oh God, now I'm having a brain fart. Hang on. 7 minus 2. Oops. Yeah, 2.6. I was questioning myself. This now is too far. We wanted to get to 0. We were almost there, and now we're way past 0. So 0 lies somewhere in between these two numbers, which means our solution lies somewhere in between 2 and 3, right? If our solution is whatever x is when y is 0, 0 is somewhere between here, so our solution is somewhere between here. So it says the graph intersects the t-axis in between 2 and 3. And we can see that. It intersects it, I'll do the red pen, right here, which is in between 2 and 3, right? We don't know exactly where. It's somewhere in between here. But closer to 2. It's closer to 2 than it is to 3. It's closer to 0.6 than it is to negative 2.6. 0 is closer to that. It will take you and your cousin just over 2 hours to reach the ranger station. That's us putting it into context, right? To reach the ranger station, that's when we hit the t-axis here, right? That's this solution, the 0 to the equation. When we plug a 0 in for y is our distance. So when we are a distance of 0 miles away from the ranger station, how long did it take us to get there? What was t? That's our x value, right? So to get 7 miles to the ranger station when we're 0 miles away, time is just a little bit over 2 hours. It's not to 3 yet. It's not even halfway to 3. It's just a little bit over 2. So whenever you're finding a solution, if it's in a word problem and you have a graph that actually labels stuff, it's not just an x and a y axis, make sure you're able to interpret that graph, right? Make sure you're able to understand what are those numbers telling me. And then it says you can check your estimate by solving the equation algebraically. So real quick here, we can do that easily. All we're going to do is take our equation, d equals 7 minus 3.2 times 0, and we're going to plug, x. And we're going to plug a 0 in for d, which is our y value, a 0 in here, and solve for t. 7 minus 3.2 t, or x, it's the same thing. Just a different letter we're using. All right, so first I'm going to add 3.2x to both sides. So I'm going to get 3.2x equals 7. And then I got to divide both sides of my equal sign by 3.2. 3.2, and on my calculator, 7 divided by 3.2, can you see that? Yep. Equals about 2.19. X equals 2.19 or 2.2, right? Which seems like what we got. We're just a little bit over 2. 2.19, 2.2. That's just a little bit over 2, so that's accurate. So our 0, excuse me, our solution to this function is 2.19. It takes 2.19 or 2.2 hours to get 7 miles over to the ranger station. When we're 0 miles away from the ranger station, that means we're there. It took us 2.19 miles. All right, so let's do a couple on our own, just a couple word problems here. And then this video is donezo. All right, gift cards. Let me use a different pen. Gift cards. Enrique uses a gift card to buy coffee at a coffee shop. The initial value of the gift card is $20. The function n equals 20 minus 2.75c represents the amount of money still left on the card after purchasing c cups of coffee. Find the 0 of this function. That means find the solution. Find x when y is 0. And describe what this value means in context, right? Well, first thing we want to do is make a little table. We've got our graph over there to the right. Let's make a little table. So we've got our x and our y value. Y is n and x is c. So c cups of coffee, and I'll put x in parentheses up here. So let's say, what's on the bottom here? 2, 4, 6, 8, 10, 12. Let's do 2, 4, and 6. Let's just do that, okay? Then we've got our equation, n equals 20 minus 2.75c. And then we'll get our solution to n, which is how much money is left on the card, right? So I got to plug these numbers in for c right here and solve for the total cost. Remember, you can go back up and look at the problem. The initial value of the gift card is $20, and that's represented by n equals the total amount on the card equals the 20 you started with minus 275 times however many cups of coffee you bought, because each cup is 275, right? So you started with 20, and then you subtract however many cups of coffee you've purchased times the purchase price, and that tells you what's left. All right, so 20 minus 2.75 times 2, excuse me, 20 minus 2.75 times 4, and 20 minus 2.75 times 6. So, handy dandy calculator here. Going to do this real quick. 2.75 times 2 is 5.5. 1450. 2.75 times 4 is 9. And 2.75 times, oops. Is 350. All right, so we've got some ordered pairs here. We can graph these. We don't know what the solution is yet. The solution is when n is 0, right? When there are $0 left on the card, how many cups of coffee did I purchase to reach that $20? Okay, so I'm gonna graph these over 2 and up 1450. So 14 would be right halfway in between here, so it's just a little bit over halfway because this line is 12 and this one's 16. Pay attention to your units of measure. Then I have 4, 9. So I'm gonna go over 4, up 9. 9 is just a little bit over 8. Halfway between these two would be 10, so it's not quite there. And then the last one I have is 6, 350. So when I go over 6, I'm gonna go up almost to 4, but not quite. Okay, so it's kind of sort of what my graph looks like. Did I go up too much? 9, no, doesn't make sense. 2.75 times 6 equals 1650. 20 minus 1650. Yeah, that's right. It didn't look linear. Just checking myself. 1450. I might not have gone up quite enough on that one. That's why it doesn't look linear, but it's supposed to look linear. Okay. So we can kind of estimate that somewhere in between 6 and 8 cups of coffee, maybe around 7, that's when our money runs out, right? That's when our money over here is at 0. It's not at 20 anymore. It's not at 16. It's not at 12. It's not at 8. It's not at 4. Excuse me. It's all the way down here at 0. How many cups of coffee would I have purchased? Looks like somewhere in here around 7. But we can go ahead and find that algebraically. Sorry, I'm not watching my phone, so I can't tell when this is crooked. I have my equation, and I'm going to plug a 0 in for the total amount in, which is really my y value. 0 equals 20 minus 2.75c. I'm trying to get c alone, and I want it to be positive, so I'm going to add 275c on both sides of my equal sign. And then I need to get c alone, so I'm going to divide by 2.75. If I'm going too fast, please let me know, and I'll go over this slower with you. 20 divided by 2.75 is $7.27. Oh, sorry. C equals 7.27, not $7.27. This means we bought 7.27 cups of coffee, right? So we bought 7 cups of coffee, and then we had a few cents left on our card. We could have bought 0.27 of another cup of coffee, but that's not how cups of coffee work, right? You can't just pay for a quarter of a cup of coffee, which this looks like our estimate up here, right? Somewhere in between 6 and 8, but closer to 8. 7.27 would be closer to 8, right? So this is our 0, or our solution. All right, and last one. Sorry, I'm taking longer on this than I anticipated. All right, distance. Same type of problem. We're doing the same thing. Excuse me. A bus is driving 60 miles per hour toward a bus station that's 250 miles away. The function, blah, 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 represents the distance d from the bus station. From the station, the bus is t hours after it started driving. Find the 0 of this function. That means plug a 0 in for y, solve for x. Describe what the value means in context. So I'm actually not going to, actually, yeah, I am. I'm going to make a table so I can graph, but then I am going to plug in algebraically to find the exact answer. Kind of wastes time to make the table when you could just cut to the chase to find the 0, right? But we have to graph, so you got to know how to come up with ordered pairs to graph. Okay, so our equation is d equals 250 minus 60t. D is the total distance in miles you are. away from the bus station after t hours. T is time, d is distance. Time is always independent. It's always our x value. So if t is our x value, that means d is our y value. So if it helps you to think of the equation like this with x and y there, then go for it. All right, so now we want to graph. First I'm going to solve. I'm just going to go ahead and do it. So I'm going to put 0 in here equals 250 minus 60x. I want to solve for x now that y is 0. So I'm going to add 60x on both sides of my equal sign. 60x equals, there's like a hair or something, 250, and then I have to divide both sides by 60. You might be off the page here. Nope. So 250 divided by 60 is 4.17-ish. I estimated it's 4.16 repeating. So I'm going to say 4.17. Okay, and remember, x was our t variable, which is time. So this is saying when we are 0 distance away from the bus station, we started somewhere over here, right? Here's the bus station. I'll make it a little pretty house. Here's the bus. The wheels on the bus go round and round. I can't draw a bus. Pretend like that's a bus, right? The bus is going towards the station. So it's 250 miles away. So it goes for a few hours, then it's a little bit closer. It goes for a few more hours, then it's a little closer. How many total hours did it take to get to the bus station? So when the distance between the bus and the station is 0, when we got all the way there, there's no distance anymore, we plugged a 0 in for d and we solved for t, which was our x value, and we got 4.17. So that means it took 4.17 hours to get to the station. 4.17 hours for bus to get to the station, right? All right, so now we have to graph. Well, I know that when this is 0, I'm going to go over 4.17, which is, excuse me, the struggle is real. This dry throat, yuck. All right, so I'm just going to go a little bit past here. I know my dot's going to be somewhere here. I could also go, remember we talked about standard form in that first lesson last week? When I have a standard form equation, I have to find my 2 intercepts. So I plug a 0 in for x to find the y-intercept, plug a 0 in for y to find the x-intercept. Well, I just did plug a 0 in for y to find x, so now I'm going to plug in a 0 in for x and find y. And that'll be my graph, right? So my equation that I used was y equals 250 minus 60x. I already plugged 0 in for y to solve for x, so now I'm going to plug a 0 in for x to solve for y. So y equals 250 minus 60 times 0. 60 times 0 is just 0, right? It goes away. And 250 minus 0 is just 250. So my y-intercept is 250. So when x is 0, y is 250 right here. And once I have 2 dots, I can connect them with a line, right? And in a problem, oh, that was not a straight line. I hope your line was so much straighter than that. In a problem with time and distance, our line actually is not infinite because we can't go negative distance, right? If y is my distance, distance is never negative. Because if you go forwards 3 feet or backwards 3 feet, you still went 3 feet. You didn't go negative 3 feet, right? You still moved positive 3 feet. So distance is never negative, so I can't go down here anywhere. Time can never go backwards. It's never negative, so I can't go back. So really, my line can't extend either way. Can't go this way, can't go this way, so that's it for my line. Just make it a little straighter than I made mine, but that's it. If you have questions, let me know.